Hi everyone. Today I'm going to discuss about how to run an L3 call, which is basically the LTE setup I'm going to discuss. So probably like you might have seen in different companies where you can run with the kind of a simulators and other things. So most of the people are not aware of how I can run, or maybe it will be better if I can see something like everything at one place without any imaginations. Because for example, if a person who is working in the UV side, he might be imagining something like what would have happened in the base station side. So like that, if you have some idea about from what is currently happening at the base stations at any given instance. So in that situation, okay, you can just imagine if everything is working at the same place, then it will be very much helpful. So that's the main intent of today's video. Hi, this is Sriram Bugude. So I'm the founder of iSignal Research. So today we are planning to discuss about this part. Let's try to jump into this. So here, if you try to have a look at here, I have just opened four terminals, which is Linux terminal. I'm just naming it as a different names. So the first window I'm naming it as EPC. So to just give the clarity, which window having the traces of EPC, and which window is having the traces of eNode B, and which window is having the traces of UV, and we can test something. That's why you can see here. I'll just keep some ping or logs, something in this particular window. Okay, so basically this is one of the code which I have and built related to LTE, whole LTE setup. So it has multiple configurations also. I think you can check it out in the previous video related to the configurations. But in today's discussion, I'll talk only about how to run the EPC. So there are how to run the whole LTE setup, including the user plane traffic. Uh, so but with respect to collecting the logs, we'll try to see in the next video how we can collect the logs after completing this. Okay, so here basically the steps, some steps are there. I'll just try to show you. So this is just like built in and setting some configurations. Now the coming to the steps, uh, separate out the namespace basically. So for that I'm going to add this one. So UV1, which means it is the first UV, I'm going to add to the network namespace, which means it is basically dividing the UV and the EPC into a different network, so that to get that field. So UV1, right, because it is already existing, I have added earlier, that's why it is showing already existing. So that we can confirm it with the help of list command. So this command is common, and I'll give the list. So that's why you can see UV1 is there. So if I try to add UV2, it will come, right? There is no problem here. So two UVs are added. But if you, this is for single UV test case. If you wanted to run for the multi UV test case, you can go ahead and add as many UVs you want, but expected that those many subscriptions present in the HSS and also UV configurations also should be present. So with this I'll start running the EPC. So this is a command for EPC. So the pre-assumption is already built, all the libraries and also the entire code base I have already built. So that's why you can able to run here all the things. So EPC I'm running, which means the expected is MME, S gateway, P gateway, and HSS and GTP, right? Those things should be initialized. So you can see it is reading the configuration epc.conf in this particular root configuration, right? So HSS is initiated, MME is initiated, all the things are initiated as a part of core network. So here we can see 001 and 01 are the MCC and MNC that we are actually considering for the test case, for the testing purpose. Okay, now I will go ahead and run the eNode B. I think in the previous videos also you can see about the interaction between base station and the UV. There is something called a ZMQ library, which is 0MQ library, which is imitating like an RF device that comes with some software library which will help us to communicate between UV and the base station. Means for the people who are not going to check with the hardware, or without purchasing any hardware, if you wanted to try within a single laptop, then you can try installing the ZMQ, so that you can get all the communication access between UV and the base station. So with this background, we can see the execution of the base station. You can see, so this is the command. So you can see here, um, I'll just paste the command. So here you can see there is something called as ZMQ, right? This is a library which is imitating, like RF device name is ZMQ. So with this, all the different RRC messages and also PSS, SSS, all the things will come into the picture. Okay, so now you can see, right? So as you can see in the left side, earlier these four messages were not there before the communication with the eNode B. Now once the eNode B is triggered, it has initialized, and also it has, this is for the tracing purpose, and once it is initialized, it has communicated to base station with the help of MME, with the help of SPNP protocol. And here the tracing is going to start. So there is no UV initiated now, so that's why the tracing is just simply, it is waiting. Okay, now here when it comes to the eNode B, what is the configuration? Okay, so configuration is basically 10 megahertz signal FDD, and single MIMO case, and also ZMQ that we have actually taken, right? So this is, and DL frequency and UL frequency, and carrier index, and PCI is 1, and number of PRBs 50 PRBs, which is 10 megahertz signal. So this is the basic information related to the eNode B configuration. So we'll trace out the further aspects according to how UV is actually communicating to the base station. So now what I'm trying to do, I'm going to trigger the UV, which means MO call from the UV side. What will happen when the UV is switched on? So that one we are going to see here. So I'm just pasting here related to UV. Again, the device is ZMQ, right? So that's the thing you can observe here. So now the moment you start trigger this one, so what is currently going to happen is MME also should find some traces, because NAS communication should happen and eNode B communication should happen. eNode B means from the RRC perspective, it means like we are actually going to initiate the L3 call. So I'm going to trigger. So what are all the things that we can expect? Random access, RRC connected, attach request, attach accept, right? Authentication, security, IP address allocation. These are all the background related to the NAS attach call flow. You can check it out, other video related to NAS attach call flow from a theory point of view. So here those things are actually happening, right? You can see. Now I hope you observed here from the NAS point of view. At the EPC side, you can see until here it was there before triggering the UV. The moment you trigger the UV, the messages that you can see all are actually coming here, right? Until here, which means IP address is allocated, right? S gateway, P gateway, tunnel ID, IMSI for this particular IMSI, authentication request and authentication response, and the authentication accepted, right? Security is provided, create session request, right? All the things are currently happening. GTPCU is created, right? This is only just L3 call success. We have not yet gone into user plane aspects, right? That's why we didn't do any activity. But while this is happening at the eNode B side, if you observe here, there is no almost no bit rate, right? Almost no bit rate. The allocated RNTA is 0.46. This is from the RRC view we can see. So you can see TTI and random access is already completed. Assigned temporary CRNTA is 46. PCI carrier component 0, right? And preamble 32 offset. All these things that you can see. But this is purely related to the parameters from physical layer and also some parameter, example 46 from RRC. Now you can see at the UV side, coming to the UV side, so random access transmission, this is successful, random access complete, network attach is also successful. But now what is actually happening here? Received RSA connection, release. Why this is actually happening? Because we didn't do any uplane activity. Means until the trigger RRC idles, we won't be coming to know that whether UV is doing any activity or not, right? So here UV is not doing any activity, so that's why you can say I will just try to ping here, which means I wanted to do something uplane activity. So now for the UV, the allocation is 172.16.03, right? 02, sorry. So the I'm just trying to ping, which means it is a downlink, which means paging is supposed to happen. Empty call now, which means now the random access again new, right? So those things that you can observe here, ping the same IP address. Now with the help of pinging, random access is successful. Now this time it is paging, which means further the triggering service request should be successful. Now you can see some of the downlink packets are actually going through, right? And uplink packets are very less actually in compared to downlink packets. So as you can see now the new RNT has been allocated and the ping is currently ongoing, right? So here this is only control plane situation. This is also control plane situation. This is some statistics with respect to the physical layer parameters, and here you can see service request is successful, paging is triggered, right? So all the things that you can see, downlink notification, which means paging, service request for that service request. So this is the just the fundamental understanding related to the call flow. So I hope you like the video. So if you like the video, you can share and subscribe and click on the bell icon for important updates, and see you again in the next video. Thank you. Jai Hind.